Now, why do we need fluent expressions? Why are we talking about it, right? So for those of you who are not familiar with using expressions, let me just briefly define them. They are uniform and non-uniform function of spatial coordinates, time, iteration, solution variables, different physical constants, and perhaps profiles that you want to assign in your CFD setup. They're simple and intuitive to use. They're just like mathematical expressions. So even if you're new to the concept of expressions, it'll be pretty easy for you to get up to speed on it. This is much more convenient than using the more traditional approach of using user-defined functions or UDFs, as a lot of us CFD users know. Those are written in the C programming language. And if you're not very familiar with the C programming language, then it becomes a whole lot of effort to understand how to write UDFs, how to interpret the different macros or different variables that go into writing simple functions for assigning complex boundary conditions and settings. So instead of doing all that, we can use expressions. It becomes much simpler to customize settings for your problem. So let me show you an example over here. This is just a converging diverging passage. Suppose we have to assign a time-varying sinusoidal pressure profile at the outlet boundary. This is how the pressure will be varying with time. You can see over here, you have an operating pressure component, and then you have some periodicity in this sinusoidal function, wherein you have the frequency to be around 350 hertz. If you were not using expressions and you were assigning this boundary condition in the traditional way, you would use a UDF. This is what the UDF looks like. And if you have no background of coding, or if you don't understand C programming language, it might be difficult for you to interpret it, right? What is defined profile? Is that a predefined macro? What type of variables do I use? Okay, now I have to convert it into an SI unit variable. I can see that there's some sort of loop in this function. What is this, loop doing? So there are so many things to understand in this UDF. It becomes quite complicated. But if you were to use expressions, and I've included a snapshot of the GUI for doing this type of a problem here, you can see that the simple mathematical expression can be entered in the Fluent window itself without you having to use a text editor or compiler or worry about writing a UDF function. You can simply write the expression over here and then assign this expression as the boundary condition at the outlet location. So this is much more intuitive, and even people who have no experience with coding can come up with this type of expression quite easily. Now, we talked about why we need expressions, but where all can we use them, right? So the previous example showed how you can use expressions for boundary conditions, but they can also be used for assigning source terms, different material properties. And then if you want derived variables for post-processing to gain extra insight from the results of your CFD simulation, that can be done as well. Expressions can also be used for printing out reports. So whatever expressions you have set up in your CFD setup, they can be included in the reports. They can be reused even by exporting them into a CSV format. Now, a little bit about the Fluent expression syntax so that it's easier for you to follow along when I write the expressions later on in the demonstration. Basically, these expressions are combinations of values, variables, different mathematical operators, and functions written in the Python syntax. Now, don't let the word Python scare you, because even if you're not well versed with Python, you can write these expressions quite easily. If you do it 1 or 2 times, you'll know how to sort of use the right operators, right brackets, how to assign the units, variables, etc. Fluent expressions are case sensitive, so keep that in mind. All types of values can be included, real numbers and integers, even Booleans like true or false. And when you're assigning quantities, you will obviously assign the magnitude, the real number that is associated with the quantity, but then the unit becomes very important as well. Units are usually enclosed within square brackets. So you can see over here, suppose I wanted to assign this number as the mass flow rate, kilogram per second, then I would have to assign this unit to tell Fluent what quantity this is, okay? Now, the other important thing about expressions is that they can either be single valued or they could return a range of values in a field. If you look at these three expressions over here, the first two expressions are for calculating the velocity at the inlet, or velocity at any flow boundary, doesn't really matter. If you look at the mathematical expression, the first one is varying with time. So T stands for time. T is a variable for time, right? And you can see that for every time step, this expression is going to return one single value. Okay, it's going to be one constant value for every time step. Similarly, in the second expression, the area of the inlet is constant, depending on how you've set up the domain. So again, this expression is going to return one single value. These were velocities. What if you're talking about heat source? Okay, so in this particular expression, it's either going to be 10 watts total user volume, user heat source, or it's going to be 0 watt per meter cube Kelvin, either of these two, depending on whether the condition is met, okay? But at any given point, it's going to be either 10 or 0. So again, it is single valued. Now, what if your expression was varying with spatial coordinates? Say, for example, here, the velocity has some function in which you are taking into account the radius of the flow boundary. Now, the radius at every point is different. Why? Because the coordinates are different. So at every point, x, y, z is different depending on how you've built the mesh. So this expression is not just returning you one single value, it's returning an entire field, something that you can plot as a contour once your simulation has completed. Okay, so the distinction is important because in Fluent, some input variables will only accept single valued expressions. So if you try to, enter a multi-valued expression over there, it's going to give you an error. So that is another distinction that you need to keep in mind. The other thing about expressions is that sometimes they need extra context. You may want to print out the mass fraction of a particular species in your CFD simulation, but unless you tell Fluent, okay, which species are you talking about or which phase you're talking about, you're not going to be able to get the right answers, okay? Now, this is just, a slide for the different units for most of the frequently used variables. You can see that these are not just restricted to SI units. You can use all different types of units. Fluent eventually converts everything to SI if that is what you've selected in your setup. But I just thought if somebody wanted to pause and look at the units later on, this might be a helpful slide. The thing about units is you need to keep in mind the general format for how you assign them. So I already mentioned that they go in square brackets. Usually there'll be a multiplier. Say, for example, you want to look at nanometers. So, you would put an N before M just to make sure that the multiplier is there. And then, it'll usually be raised to some power depending on which variable is intended for assignment, right? So say, for example, if you're doing meter per second, then, second can be raised to -1 because it goes in the denominator. And so you can raise it to the power with the help of this caret symbol over here. Now, the other thing about units is usually when you have a multi-string unit with variables, multiple dimensions in the same unit, then make sure that you put a space in between the different individual units over here. So you can see there's a space between kilogram and per meter, and then per meter and per second. So that's how you can differentiate between different dimensions and multipliers, all right? The thing about units is they need to be consistent. I'll talk about it in detail in the following slides, but suppose you want to enter an expression for the velocity at a boundary, then make sure that at the end of the expression, the value that is returned has the same unit as the velocity field that it is going to. So if it comes out to be meters squared per second instead of meter per second, then Fluent is going to give you an error. So you can see an example over here, okay? Here we are dividing feet cubed per minute by area. Now, directly, you're not assigning meters squared per second or feet squared per minute. But what happens is because there is this division function over here, if you look at the dimensional consistency between left-hand side and right-hand side, your left-hand side is velocity, so it is L1t minus 1. And then on the other hand, you are dividing feet cubed per minute by area, so it again boils down to the same dimension. So this consistency needs to be maintained, otherwise Fluent is going to give you an error. All right. So here's a snapshot that shows you what type of error you can expect. Fluent was expecting kilogram per meter cube per second in this field, but we entered kilogram per second, so it immediately gives you an error. You enter the right units, and that's going to work just fine. Now, how can we assign expressions, right? Is there just a single way of doing that? Well, no. You can assign the expressions directly in the field, directly where you assign the boundary conditions for a particular flow boundary or a cell zone. So over here, we are assigning some velocity at the inlet, and you can actually type out the mathematical expression in the GUI itself. You don't need to go anywhere else. But alternatively, what you can also do is you can use the named expressions or expression editor in the outline view, and then that gives you some additional functionality because you're writing the same expression over here. But as you can see from the snapshot, you also have a context menu right next to it. And this allows you to drop down, say, for example, functions, variables, constants, and look at all the options that are available to you. So if you're starting off with expressions, I would say this would be the better way because it'll tell you a lot more things than just directly assigning the expression in the boundary condition box. Now, what additional things can we know from using the expression editor? So this is like a full snapshot of the expression editor. It shows you one of the context menus over here. Say, for example, you want to find the average temperature at the outlet, okay? So if you click on functions, it's going to give you all the functions, all the averaging functions that are available to you for using. This is very similar to using an averaging function from report definition. Those of you who are familiar with Ansys Fluent, we do that quite often, right? Once our simulation is complete, we'll go to report definition. We'll either look at area weighted average or mass weighted average of different variables. Same functions available to you in the expression box as well. So you can look at the list of all mathematical functions, conditional statements, everything that you want to use using the expression editor. It also allows you to look at the syntax in a more comprehensive manner. You can do a couple of more things with the expression editor. So over here, if you see, while you're writing the expression, if the expression is not complete, or if the expression has incorrect syntax, you can usually tell by the indication of this red box, or there will be a message that says incomplete expression over here. So this is only in the expression editor. This is not shown to you or known to you if you start writing your expressions directly in the boundary condition box, okay? The other thing is, say, for example, you have initialized your case, right? So there is some data available at every cell. Now, if you've written an expression and you want to calculate its current value, say at the initialized stage, or maybe after a particular run, like, it has some time has lapsed at some particular time step, you want to look at the value of an expression, you could also go ahead and do that. If you click the green button, it's going to return the current value of the expression based on what you've assigned it, okay? Now, again, this is only for single valued expressions, right? So if your expression is varying with spatial coordinates, then it cannot give you an entire field. But if it is a single valued expression, you should be able to compute it in the editor. The other things that you can do with the expression editor is once you've entered an expression and you've set up your case, say, for example, you have a function that you've assigned to some boundary, it's going to tell you where all this expression is being used. So one look at the editor and you can tell, okay, I'm using this expression over here, I'm using this expression over here. You can also assign these expressions as input and output parameters in Workbench. And that is very convenient. Say, for example, in this expression, we want to do several design iterations by varying the value of omega. Now, if you set omega up as an input parameter, or if you set up this entire expression as an input parameter, you only need to check this box, and then you can enter the different design points in Workbench and update the various design points through the Design Explorer. So using these expressions as input and output parameters is also possible. The other thing that I find quite handy is sometimes when you are assigning mathematical expressions, you want to look at them in the form of a graph, just as a gut check to understand that you've assigned it correctly, okay? So say, for example, this is a sinusoidal function. You want to make sure that you've assigned this correctly, right? Your expression is right. So you also have the option inside the expression editor to assign a minimum and maximum value. And based on the mathematical function you've entered, it's going to plot it for you. So this could be a good gut check to make sure that you've assigned things correctly.